And we're live. Alrighty. Alrighty. Hello, everyone coming in. We'll get started here in a moment. All right. Hello, everyone that's joining right now. We'll get started in about 3 or 4 minutes. Going to let a couple other people join. And so just hold on. Go get a cup of coffee, glass of tea, uh, a case of beer, or a glass of water, whatever your fancy is. All right, well, my clock says 1:30 Eastern time, and I see a couple people starting to join us now. But we're going to go ahead and get started because I want to keep this to under an hour. I don't want to take up too much of your time. So we're trying something new with this, using Google Hangouts to do a webinar. If you want to post any questions or have any comments during the session, the page that you were brought to should have a discuss at the bottom of it. Just add your question or your comment there, and it'll be on the list for us to take a look at here in a couple minutes. Um, if you're looking at the questions and you see something you're really interested in, upvote it. Any upvotes will be answered first towards the end of this webinar. So without further ado, I'm going to bring my screen back up, and we will get started. So thanks again, everyone, for joining us. This is using SignalR to build real-time web applications. And if I didn't say so before, my name is Kevin Griffin. I'm a independent consultant from the Norfolk, Virginia area. Uh, you might have seen me around on the Twitters, or you've been to my website once or twice. If you ever need to get in contact with me for any reason, please hit me up on Twitter or shoot me an email. I'm a Microsoft ASP.NET MVP, and I've been particularly focused in SignalR since its early inception. Uh, so I like to say I know quite a bit about it. There's a lot of great use cases for it, and a lot of people just have trouble finding those use cases. And I'm hoping today we can answer a lot of the questions that you might have. First, a couple things that I'm working on that are particularly cool. I'm the CTO of a service called Winsitter. So if anyone out there joining us is a part-time Windows Server admin or they play one on TV, you might be interested in Winsitter for monitoring your Windows servers. Um, we give you real-time updates of anything that could potentially be going wrong. So if a server's going down or a certificate's getting ready to expire, and you name it, we probably monitor it. And you can try it today for 14 days free, no obligation trial. And that's winsitter.com. On the same note, we just recently pushed out a new service called Patch Tuesday, which is dedicated towards scheduling and controlling Windows updates across enterprises. So if you find yourself in a situation where you need to manage when and how Windows updates are installed across your enterprise, that can be kind of daunting to do, especially uh, with the more machines that you add. PatchTuesday.io takes care of all that for you. And we're launching into a private beta very soon. Uh, so if you go to patchtuesday.io, you can get on that list. And then lastly, I'm an author for When to Select Now. And in particular, I have a SignalR Master Series up there. If you go there today and use Griffin13 for the promo code, you'll get a no obligation 2-week trial. So you can go watch as many videos as you would like to and hopefully get quite a bit out of that. The SignalR Master Series, I have to add, is much more involved than what this webinar is going to cover. Now, this webinar, I've told some people, is Module 1 for all intents and purposes. And that's going to be out of 7 different modules. So once you get through this, if you really want to dive in more and see what kind of control you can get over SignalR, go to winselectnow.com, put in the promo code, watch the videos, and then go watch some other stuff. All right, because we only have an hour, this isn't going to be a very in-depth webinar to begin with. It's going to be more of a 100-level introduction. So if you've never done anything with real-time web applications, if you've never done anything with WebSockets, or you've never heard of long polling or server-sent events or any of these crazy words I'm going to throw out there, this is probably going to be the session for you. And first, we're going to start with the history of the web. How did we get to this point where we need something like SignalR to help us build real-time web apps? We'll talk about how we've done it before SignalR, and then we'll talk about where SignalR comes in and fills a lot of the holes that we see. All right, so first things first, how does the web work? Well, a brief history of the web. Let's call this the AOL days, or version 1.0. You would sit down at your machine, you would dial into AOL, and you would bring up the web browser. And you would type in, I want webcrawler.com. Well, somewhere out in the magical internet, there's this thing called a server. And your request goes from your web browser out to the server, and then the server churns on it for a moment and sends a response back. And this is how everything worked. The HTML would come back to your browser, it would get parsed and would realize, hey, I need to go pull some additional files. So I might need some CSS, I may need some images, and all that's going to get sent out as requests, and then the data is going to get brought back to us as a response. We're going to graduate a couple years into the future, and this is the Web 2.0 days. We still have a similar infrastructure. I have a client machine I sit down at, but instead of typing webcrawler.com, I'm going to Google in this case. And everything goes out still as a request, and everything comes back as a response. And this part hasn't changed. The only difference is now we're adding in keywords like Ajax, and we're doing more stuff on the client asynchronously. So not only are we bringing back assets, but now we're making asynchronous calls to different endpoints. So RESTful services, whatnot. And I like to say that now we're finally graduated into Web 3.0. And this is where we're seeing ourselves developing applications that uh, work on the web, but they act like thick clients. These are very beefy web applications. I still have a client and I still have a server, and the connection between them hasn't changed. I'm still sending requests to the server and I'm still getting responses back. Except now I need to have this magical additional connection in between them. And I call this a continuous connection. Every time my client does something, it's going to send a message to the server. But if I have tens, hundreds, thousands, millions of people all connecting to the same web application, I probably need to keep some sort of sync in between each and every one of them. The modern request response cycle can do that, but it's not appropriate for that. There's a lot of baggage that comes with handling that. But having a continuous connection between the client and the server allows my server to, at any time, send messages down to any or all clients saying, you should update something on your screen. So when we define real time, we can easily say it means that we're updating the client without interaction from the user. And if this was an in-person presentation, I would go around the room and ask you all to define an example of a real-time web application, something that you might use every day. Some common examples. Gmail. People use Gmail all the time. If I'm sitting here staring at Gmail and my buddy Chad is down in North Carolina, he sends me an email. Do I need to actively refresh my Gmail screen in order for that email to pop up? And the answer is no. It's not going to happen immediately, but it'll happen within a minute or two. And that's because Gmail has detected that the emails come in, and it's going to send a broadcast down to my Gmail client in the browser saying that a new email has come in. And first it might just be the subject and the from line, but then later it's going to send down the information for that particular email. Another great example is Facebook, something that a lot of people probably use, and some of you are probably on Facebook right now. And when you're on Facebook, you can sit there and you can look at different status updates, and for each status update, there might be a number of likes and a number of comments. Well, if you're looking at a status update at the same time someone else is looking at a status update and they make a comment, you don't have to refresh your page in order to see what that comment was. It's just going to automatically pop up at the bottom of the status update. There's no interaction from you. So what we want to do is we want to do this in our applications. Our applications should be as cool as Gmail or as Facebook. And how do we get around doing that? Well, let's imagine we had no idea what SignalR is, what the concept is at all, and we wanted to implement a feature like this in our own code. How many different methods are there for us to do this sort of work? Well, the first one's pretty obvious, and I see this all over the place. It's the easiest thing to do that works across all browsers without any issues, and that's interval polling. And the concept's pretty simple. I make an Ajax call to my web server, possibly asking for information, and it's going to come back immediately. I have information or I don't have information. When that request comes back, I'm going to send a timeout. In the case on the screen, 10 seconds. And in 10 seconds, I'm just going to make that call again. And then 10 seconds later, I'm going to make this call again. I'm going to do it over and over and over again. And there's a couple pros to this approach. The first one is it works across all browsers. You could go back to IE 5.5, IE 6, which some of you probably have to support, and this works, and it works really well. Uh, the problem is we're dealing with a lot of connections, and for every connection that we're making, there's a lot of overhead for that connection. The more overhead we have, the more bandwidth that we're using, and if we're doing this for every person that's looking at a particular page, we're putting a lot of strain on our server. So let's imagine there's 1,000 people on the web page, and 1,000 people are making a connection every 10 seconds, no matter what. That's a lot of connections coming in at one time. Now let's bump that up to maybe 500,000 concurrent connections. You could very well DDoS your own server without realizing it. Method number 2 is long polling. And this is kind of the next graduated step up from interval. And the simple way of explaining long polling is I'm going to open a connection to my server, and that service call is going to remain open for as long as they need to until the server has data it wants to return to me. And most browsers, this is going to be up to 120 seconds, in which case the call is going to fail, it's going to time out, and no matter what, we're going to initiate a new call. So at any one time, there's a call openly connected back to our server, and the server can use this as the pipeline to deliver data down. And what's nice about this? It also works across all browsers. So if we go all the way back to IE6, this works just fine. We're consuming less in overhead, so this works very well on our servers that might not have as many resources. We're not going to use as much. We're making a connection a minimum of, or a maximum of 2 minutes across every connected client. And if we're making multiple connections, so one person's getting a stream of information coming down, those are all warranted calls. So we're not wasting any bandwidth on a call that's not going to return something substantive. A couple of cons of this approach. We still have to make connections on a regular basis. I really don't like having to make a connection back to the server every time I want to sit there and wait for data to come down. So we still have this, and it's not great, but it's good enough, especially if we're on older browsers. And method 3, now we're getting a little advanced, but this technology has been around for quite a while. And server send events. And the idea here is I can open a pipe from the server back to the client, and the server can send messages down to me whenever it needs to. And this has been around since the old Netscape days. Some pros of this, the server can send data to us whenever it wants. It's an open pipe. The big con is it's one-way communication. So only the server can send data down to the client. The client can't send messages back up to the server. And all right, how do you get client messages up to the server? You're going back to the old AJAX method of let's make a post request or a put request to the server to send our information up. Also, if you're supporting Internet Explorer, you're probably not going to use server send events. And there's other methods, but I'm going to end with number 4, which is WebSockets. And WebSockets is what I call the holy grail of connections. It's a connection from our client back to our server. It's always open as long as the connection's good, and the client can send messages up the WebSocket, and the server can send messages down the WebSocket. So it gives us that true bi-directional communication. I call this the Holy Grail because this represents what we really wanted a couple slides ago, of a true peer-to-peer connection between our server and our client. Some cons of this approach. You're looking at newer generation browsers that support this. And necessarily when I say limited support on older browsers, I mean more in particular IE, old Chrome, old Firefox, old Safari. most of you probably aren't supporting old versions of those browsers, but you probably have to support old versions of IE. Also, because we're .NET people, we're limited to IIS version 8 or greater to get WebSockets. Wow, that really sucks because you have to be running on at least Windows 8 or Windows Server 2012 to get this sort of functionality. If you're pushing up to Azure, you're getting this out of the box. If you're pushing to Azure websites, you have to make sure you turn on WebSockets. Overall, it's really coming up in maturity, so more and more people are able to use it. Now the question comes into, well, Kevin, you just gave me 4 different solutions for doing peer-to-peer connections from a client to a server, but you also gave me a list of support. So it depends on my client and it depends on my server. Does that mean I need to write 4 different implementations of my client to server code? And the answer is no. That's where we introduce SignalR. A really easy graph of how SignalR works is like this. Out somewhere on the internet, we have people that need to connect to our services. And I'm going to call these our connected clients. And on the other side of the equation, we have what we call a SignalR hub. Now I'll show you hub in code here in a moment. And this is going to be the server connection that lives in either an ASP.NET site. You can also self-host SignalR, but somewhere there's this endpoint that our clients are going to connect to. And in between is the transport. And the transport is going to be how the clients connect to the SignalR hub. Let's say, for example, our SignalR hub is running on, or running in an ASP.NET site, and it's running on IIS 8. And I have a couple different clients. One client's running in Chrome 85, whatever the current version is. It's going to connect to SignalR via WebSockets because that's the best possible way for it to connect. But if I have another client who's running in IE7, IE8, heck, IE9, they're going to connect to the same SignalR hub a little bit differently. And it's going to fall back to long polling, or it's going to fall back to another transport called Forever Frame. And both these clients are connecting to SignalR, and they're connecting to the same SignalR code. The transport level is going to be what determines how they connect. So you write all your server code, and you write all your client code, and SignalR is going to be this magical piece in the middle that's going to make both sides talk to each other, no matter what your client situation is or what your server situation is. That means if you deploy an app now to IIS 7 and it works just fine, but it's never going to use WebSockets, let's say 6 months from now you get to upgrade that server or you redeploy the app to a newer server. Without any code changes, all your clients that can support WebSockets will now take advantage of WebSockets. You don't have to make any code changes on your part. And that's where the real power of SignalR comes in. A couple simple ways to get SignalR. You can either go straight to GitHub and pull it down. You could do that, but it's probably easier just go to NuGet and pull the code down yourself. And that's what we're going to do in our demo. And before we go into demo, I'm going to look at questions and see if there's anything I need to answer before we go in. Quick check. And once again, everyone, you can use the discuss at the bottom of the page to ask any questions. All right, I don't see any, so I'm going to move on. All right, let me close all windows here. So first, just a quick demo of what we built. And the most SignalR applications are going to be chat applications because that is the simplest thing that you can build without putting a lot of effort into it. And if you go back through some of my old blog posts or even through my YouTube channel, I've done the real-time chat application before. and it's really simple. So I decided to step it up a notch, and I built this demo called Move the Mouse Inside the Box. And if you move your mouse inside the box, it's just going to draw a trail of where the mouse move events fire. So it's nothing special, nothing real crazy. If I move the mouse, it's going to plot a dot and just follow my mouse around. The code for this is pretty straightforward. It's a basic ASP.NET MVC application. I've hijacked the index to add a big canvas and a couple scripts. Actually, skipping ahead of myself. So I have one JavaScript file, which if I open it, it just has the logic for plotting that particular, plotting on that canvas. Though the important part is, if I mouse move anywhere on the canvas, it's going to fire an event, and I'm going to increment a pixel. Basically, I'm just going to turn the pixel black. So that's how we make the screen do what the screen needs to do. Now, our use case is I want to make this multi-user. I want to have one canvas that shares events across everyone's view. And I'm going to use SignalR to approach that. I'm going to stop running here for a moment. And we're going to start with the basics. How do I pull SignalR into this app? I can go to GitHub, I can pull it down that way, or I can go into good old NuGet and I can search for SignalR. And what you're going to notice first is there's a whole bunch of SignalR stuff in here. And what you need is totally going to depend on your use case. The one that you probably want to use 99.9% of the time in ASP.NET apps is this very first one that's just Microsoft ASP.NET SignalR. If you click install on that, it's going to install a couple different dependencies. In particular, it's going to install all the Owen packages and the JavaScript client for SignalR. And press close. When you do the install, a README is going to pop up with some configuration information. And the one piece you really want to pay attention to is going to be right here about mapping hub connections. We haven't really talked about hub connections yet, but all you need to do is copy and paste this one line of code into your startup CS file. And depending on how you created your application, you may or may not have it. I deleted it from this package so I can go back and add it. So I'm going to add a new item, and I'm going to add an Owen startup class. And I'm just going to call it startup. And I'm going to say app.map SignalR. All right. I don't know why my IntelliSense isn't working, but that built no problem. All right. Let me open that up again. Okay. Yeah, I'm not sure why the IntelliSense isn't working, but we'll go past that. This line is what configures SignalR inside your application. It's the guy that tells Owen, which is the open web interface for .NET, how to expose SignalR to the world. And it's doing this inside the context of your ASP.NET application. There's a whole bunch of configuration you can do in here. I don't have IntelliSense, so I can't show you, but we can pass in configuration information that says how you should turn things on, how you should turn things off, how you should configure particular circumstances. So this is very adaptable. I'm going to close that. Yeah, that's weird. I'm not sure why my IntelliSense is being mean to me. Now, in order to really demonstrate what SignalR can do, we have to build both the server side and the client side and have them talk together. Because I can't really do both at the same time, I'm going to start with the server side, and I'm going to create a new hub. I'm going to put that in a folder and call it hubs. Oh, And that's what I get. Let's try that again. All right, I'm going to call it hubs. All right. You know how everything works just fine until you go to do the demo. All right. All right, let's try this one more time. We're going to create a new folder. We're going to call it hubs. Awesome. And then inside hubs, we're going to just create a new class. If you have Web Essentials and stuff like that installed, it'll give you an option for a SignalR hub class. You can use that too. And basically, it's just going to do all this work by hand or automatically for you. But I'm going to do it by hand. And we're going to call ours a mouse hub. And think of a hub as a central connection point for connections coming in. It's like an ASP.NET MVC controller. You're going to put stuff that's focused around a single responsibility inside this hub. Because all I want to do is report on mouse movements, I'm going to call it mouse hub. You can have as many hubs as you want. And to make it a true hub, you're going to inherit from ASP.NET .signalr.hub, which I'll pull in the reference here. I have no idea why none of this stuff isn't working. All right, so we're going to add a method in here, and we're just going to call it move. And we're going to pass in some parameters to move of basically our x and y. And I'm going to call these mouse move coordinates, which doesn't exist yet. We're going to have to go create that. So I'm just going to create that in models. So we'll do new class, mouse coordinates. And then inside mouse move coordinates, I'm going to create two properties. And I'm going to say string x coordinate, and we'll make that automatic. And then we'll create y coordinate. We'll go back over here to mouse hub. We'll pull in the reference. So move is going to be called by the client eventually. We haven't written that code yet. But what we want to do is when that move comes in, we want to send it to everyone else that isn't me. Because I'm inheriting from hub, I get this special class called client, or clients. And I really wish I had IntelliSense right now. All right. I want to try this real fast, just see if I can get my IntelliSense back. I'm going to reload the project. Do we have a winner? Do we have a winner? We do not have a winner. All right, that is so weird. All right, yeah, everything works just fine. It's just not pulling IntelliSense. All right, well, we will push forward. All right, so if I had a client's object with IntelliSense, it would give us a bunch of different connection options for sending out our messages. So clients represents everyone that's connected to our web server. So just not your connection, but every connection. And When I say every connection, I'm not talking about individual users. I'm talking about individual tabs or windows. If I open up a SignalR based web app on 2 or more tabs, they're all going to have unique connections back to my server. And there's a couple different options in here. And what I'm going to do here in a moment after the demo is I'll bring up the fully baked demo so you can see all the options. And the one in particular that I'm going to worry about is called Others. And what I want to say is, for all the clients, I want to send it to all the other connections that aren't me. And you'll see in a minute why I don't want to do that. I don't want to send myself a message if I'm the one that initially sent it. And what I'm going to do is I'm going to say, you should call a method called register movement. And we're going to pass the coordinates that we got in to that method. Now that's all the C# that we're going to write for now. When I get a request coming in for some mouse coordinates that moved, I'm going to send it to everyone that's not me and tell them you should call a method on the client side called register movement. And here are some coordinates for you. So if I run this, give it a second to come up. I'm going to go up here to my address bar, and I'm going to call SignalR /hubs. And what you'll notice is this doesn't actually exist anywhere inside our solution. Now we have a hubs folder, but we don't have a SignalR /hubs folder. If you remember in our startup class, we mapped SignalR. What that did is it went into our route table and it created a route that said, if I ever get a request for SignalR /hubs, I want you to go create a mapping for me. And I call this a proxy file or a client proxy file. I'll zoom in a little for you. And this tells SignalR how to connect back to your application. In particular, how do you connect back to one of your hubs? And most of this you just don't have to worry about. But what I'd love to show you is down here at the bottom, where SignalR is generating dynamically our mouse hub, the mouse hub that exists on the server. And it's creating 2 objects on it, one for client and one for server. And the client has nothing in it. And here in a moment, we'll show you how we can add some stuff to it. But under server, I have a single method called move. And that's move method takes one parameter called movement. If I move back over to mouse hub, we'll see I have a method called move, and it takes one parameter called movement. It's a one-to-one mapping of all the different functions inside of my hubs. Because it's defined like this, I can use move fluently the way I would want to inside JavaScript. So let's go back into our view. Oh, we have it open right here. And I'm going to add a script tag for SignalR /hubs. And then right before that, I'm going to add a reference for SignalR. So if you look inside my scripts folder, you'll see I have jQuery. There is a jQuery dependency with SignalR. The installed version is only 1.10 because that's what's in the template. But if you're using jQuery 2 or whatever, that's fine as well. But what we care about is the SignalR 2.2.0 or whatever the current version is at the time you're doing your work. We're going to pull that in. One note about the jQuery, because a lot of people ask me about this, is the jQuery dependency going to go away? The way that web frameworks are working nowadays, you don't necessarily need jQuery in your application. and depending on who you're talking to, they might scold you for using jQuery. Uh, it is on the timeline. From what I've heard from the ASP.NET team, when SignalR version 3 drops, hopefully in the near future, it will no longer have the jQuery dependency. That means you get to come listen to me talk all over again about how to use SignalR now without the jQuery dependency. But for now, we need it. It's getting injected inside of our layout page, so we don't have to worry about that. I'm going to come back over here to my app, and I'm going to do a refresh just to make sure that everything's working the way that I expect it to. I want to show you a couple debugging tips while we're in here as well. All right, so that's all good. So now inside this app, I need to do a couple things. I need to set up my client connection back to SignalR, and I need to tell SignalR what to do in the case of that register movement method call. So what happens when this method gets called on the client? And we're going to do that all down here at the bottom. And the first thing I'm going to do is get a reference to my mouse hub. As I said, there's a dependency on jQuery, and SignalR builds off of the jQuery object. So if in your application jQuery isn't mapped to the $, you use whatever construct you're using to talk to jQuery. So if you need to talk to jQuery directly, you can do that as well. And this mouse hub object is going to point directly to, do I still have it up? I do. Point directly to this proxy that gets created. So it should be defined as something. And on the mouse hub, I'm going to go into the client object. I'm going to add a new method called register movement. And I'm going to pass it as a function that takes movement. I want to increment a pixel. And I want to say movement, that's what we call it, x coordinate, and movement y coordinate. But you know what? I really don't want to type out x coordinate or y coordinate because I don't want to deal with camel casing issues. I really just want to call it y or x and y. So before we move on, I'm going to go back into my move coordinates, and I'm going to set a JSON property. I'm going to set name. I want to set JSON property to X. And I want to set JSON property to Y. So when SignalR sends all this data from the client to the server, it's all going to go as JSON because it's pretty cutting edge. And I don't want to have to deal with JSON conversion from different cases. So I can tell SignalR, when you send this data across the pipe or when you get data in, map X to X coordinate and map Y to Y coordinate. And it's going to do that both ways. So now I don't have to worry about having super long case sensitive stuff inside my JavaScript. It also cuts down on bandwidth. I know it's only a couple of bytes, but the more and more content that you have inside your objects and you're sending them across the pipe, and you add more and more users and more connections, that bandwidth can add up. So every little byte that you can save can help. So because I did that mapping, I can now assume that X and Y are both going to be there. And then I need to start my connection. So if I go into SignalR and say hub.start, that's going to initiate the transport negotiation. It's going to ask the server, can I connect via WebSockets? Can I connect via server send events? Can I connect via forever frame? Eventually until it just settles on long polling. That's kind of the final answer. If it can't connect long polling, it just can't connect. you have an issue somewhere. If I do that, and the line before that, just for fun, I'm going to turn on logging. So if I say connection.hub.logging, oops, don't you love when IntelliSense is 10 steps ahead of you? If I said login to true, SignalR is going to spit a whole bunch of information out to our client console. So if I run this again, I'll show you what that log looks like. And down here at the bottom, it's going to start scrolling. See if I can zoom in a little bit on it. And this is SignalR doing all of its negotiation. It knows that we're talking to Mouse Hub, so it's going to subscribe to any events coming down from that Mouse Hub. And then it's going to start transport negotiation. So it's going to try to do WebSockets, and it connects successfully to WebSockets. We can tell that it opens correctly, and it's going to keep monitoring that connection. Let's say I do something fun like pausing my IIS server. And I come back over here. If I wait a moment, what should happen? We'll see that SignalR missed a connection heartbeat back to the server. So it's going to keep trying over and over again. The WebSocket's going to close because it can't talk to the server anymore. So it's going to try again. And it's going to do that for a period of time. In fact, it's going to do that for 20 to 30 seconds. In which case, when it's all done trying, it's going to just fail. It's going to disconnect. If I hit replay on this, if I did that fast enough, we'll see it was able to reconnect to the WebSocket, and it reestablished all the connections again. And SignalR does this for you out of the box. We can configure the timeouts and all that good stuff. But it's really fun to see how SignalR is working underneath the covers. So I can move the mouse on here, but it's not really doing anything because it's not sending those messages back to the server. So that's the last part we have to implement. If I go into my app.js, I'm going to go down here to my on event. And I'm going to do a quick connection check. If the hub state is equal to 1, that means connected. You really wouldn't know that unless you went and looked at the documentation. So you can just trust me. If the state is 1, it means it's connected. The other states could be it's disconnected, it's trying to reconnect, or it becomes reconnected. If all that works well, I want to go up to the server and I want to call the move method on it and pass in my offsets. So call and move, and I'm passing in an object, the way I would in JavaScript. And what should happen is this object gets translated into a mouse move coordinates object, and the move method gets called. So let's put a breakpoint here just to see what happens. I'm going to refresh this page, and I'm just going to kind of move inside the box. Visual Studio is flashing at me. I can come in here. Let's look at my move object. All right, I have an X coordinate, I have a Y coordinate. That's then going to get passed on to anyone else who's connected. Because there were a lot of events thrown, I'm going to disable the breakpoint. And we can watch out at the bottom. It's invoking different methods. And it gives us 2 different types of events, the invoking and the invoked. So we know how to handle both. All right. I'm going to open up another browser window, which would create another connection to SignalR. I'll refresh this first one so I have 2 clean slates. Oh, and you can kind of see what's happening here. As I move one mouse in one, it reflects over in the other. Now there is a bit of a lag because I'm sending a whole bunch of events at the same time, and I also have logging and diagnostics on, which is never good. So I'm going to go and turn that off, and it will help a little bit. And then there's Hangouts lag, so sorry about that. It is much faster when you're sending these many events. Uh, Let me give a good refresh here. All right, that's loading up. Refresh. All right, so now if I move the mouse, there's still a little bit of lag, but that's really just my machine. Um, but you can see I have that one-to-one connection between one client and the other client. And if I move my mouse on the other side, you'll see that it updates. So cool. We have a one-to-one connection across all these different browsers. And if I were to open another one, and see how well I can do this with all these windows. Refresh, refresh. So it's hard to get them all on the same screen so you can see, but you can kind of tell. I'm moving my mouse around and they're all updating in sync at the same time. So cool. We've accomplished the goal that we set out for. All right, and what I'm going to do really fast is I'm going to shut down this solution, and I'm going to come over here. I'm going to revert some changes, so I can get you that IntelliSense back, and I can answer some questions. Let's see, SignalR. All right, let's try this one more time. I don't know why the IntelliSense broke on me. It was actually working just fine a couple of minutes ago, and then I sat down to do a demo. So if I go to my mouse hub, that's crazy. Cannot. All right. Alrighty. Well, I can't obviously do anything without the IntelliSense. But if you were to open that, you would see all the different contexts that you could send information to. I'll point people back to my SignalR reference on when select now. I go really in depth into the different types of people that you can send messages to. You can get very detailed about it. I'm going to switch over to some questions and see if there's any questions. Let's see, question from Ken. Do I use SignalR with WinSitter? I do not. The backend for WinSitter isn't in .NET. It's written in Node.js. It's actually built on a platform called Meteor that does real-time syncing between the client and the server and does a really good job of that. But if it was written in .NET, I would very well use SignalR on the web app, no problem. We've even looked at using SignalR with our client agent. So the way WinSitter works is you install an agent on all your servers, and those report back to a central server. And we wanted to play around with an idea of having SignalR be our socket connection. Instead of doing real sockets, we could use SignalR to manage all this connection infrastructure for us. But there's other issues with that aren't SignalR. That's why we haven't approached it. Let's see, from Jay, can I clarify the difference between SignalR hubs and proxy types and why they're used in SignalR applications? All right, if I'm interpreting your question right, Jay, why do we use the proxy file? So let me bring this solution back up. The one thing I'm not really going in detail about is that there's two ways to talk back to SignalR. There's this most common way, which if I get Chrome to deal with me, of the proxy file. And you can either use the proxy file or you can set up the subscriptions and publish the events yourself. Um, the proxy file's really nice if you don't mind exposing to, I guess, the world how you're talking back to your server. So what methods, what everything that you can call. So if we were getting really detailed about it, if I came through and read this file and figured out, oh, if I call your server, you have a move method. What if I were to bring up my console and I know how SignalR works. So if I go to your mouse hub and I say move, and let me say x is equal to 10 and y is equal to 10, will that do anything? Oh, and I didn't have another window open, so I have no idea if that actually did what I expected to. Let me try that again. Undefined is not a method. Oh, and I also typed it wrong. I forgot to do server.move. So if I do that, okay, I returned something, which means I could come over here and I see the dot. So by reading the proxy file, I was able to interpret how the connection back to the server could work. And you might be sitting there thinking, Gavin, that's really scary. It's really not, because you publish your source code with every web page that you deploy anyway. If someone was savvy enough to go through and read it, they could figure out what your API endpoints are, how you do your authentication, how you do all this stuff. You're basically providing everyone a cookbook of how to use your application anyway. When you don't deploy the proxy file, you turn that option off. So this file becomes 404. It just doesn't get created. Now what you have to do instead is you have to go through independently and say, I want to listen for client events from Mouse Hub. Let me bring back up the JS file. So here's the example. I want to listen for an event called registered movement, and it has a function associated with it. So you're pretty much just doing on registered movement, do something. And you're creating all these subscriptions yourself. And to do a publish, you can't say mouse hub server do something. You have to say, okay, trigger an event, and that's going to send it back up to the server. What's nice about that is you're not actively exposing, you're not providing the cookbook for how to use your SignalR services. You have to already know how they work. The nice thing about not having the proxy file, if you move over to other platforms, so if I'm building a WPF application that's going to talk via SignalR back to a web app, which you can do, there's stuff out there for that. You're doing it all with subscriptions and publishing messages. So you're probably better off not even using the proxy file to begin with in those situations. Let's see. So I'm running right at about time. So Jay, I hope that answered your question. I actually know Jay, so Jay, if you have more questions, just hit me up independently. So I am going to just put up my think screen. If anyone has any questions after this, please feel free to shoot me an email, or Twitter is usually a better case. If I get a lot of the same question, I'll probably just write a blog post or do another video on this topic. But let's definitely keep in touch, because I plan on doing a couple more SignalR webinars over the next couple months on a little bit more niche topics. So if you're interested in scaling, or if you're interested in performance, or if you're interested in, hey, how do I use this in a real application, I cover a lot of those scenarios. I have at least 3 clients right now who I'm using SignalR in some capacity to solve different problems, but they're all really coming down to we need to update a view without the user clicking refresh. So, all right, well, I will stick around just for a moment. If you have any more questions, just put them up in the chat. I don't see any more coming in. I would like to thank my buddy Chad for just sitting there and watching the chat for me. All right. Alrighty. Well, thank you so much, everyone. Have a great Good Friday, and we'll be in touch. Thanks so much.